So for this problem, we got these cool hexagons that represent atoms of carbon thing, but I'm not a chemistry person. I've never been a chemistry person. Anything with chemistry usually scares me and I run away. But yeah, there's all these cool atoms and they're in the shape of hexagons. And just imagine a bunch of hexagons on like a plane. And here we're trying to figure out like where the little corners of the hexagons and the centers lie on that plane. So our first step was to basically convert. So what we're going to do is so the way that this was originally graphed was with this line here and this line here, like this. Kind of a horrible drawing, but like that was our original plane. And what we decided to do to make it easier is we decided to go like this because we were told to do that. Yeah, we were told to do that because those are our bases. So I created our new basis here, and then these are these are our basis points. So in our basis, our 1, 0 is this little vector here, and now I'm going to take that point and I'm going to times it by the new basis, and I'm going to get our old basis. As you can see, when we did this, the x did not change at all, but our y changed quite a bit. So when I do the next one, and I get negative 1, 1. So if you can see on this old, if I go left 1, up 1, that would get our new 0, 1 vector. Then we have our 2, 1. So that is 1, 2, up 1, this point. But on our old coordinate system, if we look at it, it's 1, 2, our 1, 1 position, which is exactly what we get down here. I only saw one of them that was labeled 0, and that's this one, which is the one that I started with. So that has a 0, 0 coordinate on both coordinate systems. This is 0, 0. What are the coordinates? XB, that is in our new basis of the labeled C. Obviously, I drew this, so this is really easy. Right 1, up 1, so 1, 1. And then how do the coordinates relate? I said that, so this little 1 up here, 1, 2, 3, 4, 1, 2. It's 4 right and up 2 of the 0, 0 position. So since it's in XB here, I just decided to do this in XB. So what I did here is I created these little slopes, and everything that's on this slope is the center of a hexagon, if that makes sense. Like anything that is a solid number. So this right here would be, so 0, 2 there is a solid hexagon. It's not like, it's on that. It's on the line. Where this right here would be 1, 1, 2, like 2.5, but it's not a solid number. So I took that into consideration and I created this little handy dandy formula, and I did that using this carbon this carbon one here. This is definitely not the way you probably wanted me to do this, but this is the way that made sense in my brain, and my little peanut brain did it this way. And yeah, it said that anything where B is a solid number, then it will land in the center of like the hexagon, as long as B is a solid number. But B has to be a solid number, because like if I had this going through this, B wouldn't be a solid number, and it's 1.5. So I had it start here and then every 1.5, and I could tell this was 1.5 because this is 2 of them. From C up there is 2, and it's parallel and they're the same distance apart, so that must be 1.5. So that's how I got this 3/2 times the B. Then I did a bunch of checking to see if my formula works. So these 2 points I knew for a fact were going to intersect. So if you look here, 1, 2, 0, it's at the center of a hexagon, and then 1, 2, 3, 4, up 1 is the center of a hexagon, and they should have the same B values. So I checked to make sure my formula worked, and it did. And these B values were solid numbers. But then when I went to 0, 1, which is 0 up 1, and it didn't work. So like I used my logic, and I was like, logically this should work. And then I checked a couple points to make sure it worked. And then I plugged in my numbers. So this I had as my y, and then this is my x, and then I solved for b, and I got b is equal to -3. And since -3 is a solid number and not a fraction, that means that this xb is on the center of a hexagon, or this x point is on the center of a hexagon.